All right, in this video, I just want to go over a couple more examples on 16.3. So you might see questions like this, or we have to solve like x plus 1 times x minus 1 equals 3x. You're asked to use the quadratic formula. So the first thing you need to do is FOIL this out first. So x times x is x squared. X times negative 1 is negative x. 1 times x is positive x. 1 times negative 1 is negative 1 equals 3x. Combine like terms, these guys will cancel each other out. So you're left with x squared minus 1 equals 3x. Then you have to set it equal to 0. So we're going to subtract 3x. But notice I'm going to write it as x squared minus 3x minus 1 to keep it in that standard form equals 0. And the purpose of that is so that I know what my A, my B, and my C is. So remember, A is equal to 1, B is equal to negative 3, and my C is equal to negative 1. Recall that the formula is x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So I'm going to plug that in. That becomes negative, parentheses, negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times negative 1. Again, notice every time I plug in a letter, I'm using parentheses to indicate multiplication, and then it's 2 times 1. Now I'm just going to simplify this. So two negatives make a positive. So I get 3 plus or minus negative 3 squared is 9 minus 4 times 1 is 4. 4 times negative 1 is negative 4. So that makes that a positive 4 divided by 2. And then 9 plus 4 gives me 13. And then there you go. And I believe that's how your homework would want it as well. Yes, you don't got to worry about splitting those up. All right, let's look at another one. Number 5. We're going to solve the following cubic equation by factoring and then using the quadratic equation. So you're given 3x cubed minus 15x squared plus 6x equals 0. So the first thing we're going to do is factor out that x. So I'm left with 3x squared minus 15x plus 6. And then I'm going to use this piece as my quadratic equation. So this will be my A, this will be my B, this will be my C. So again, my equation is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In this case, my a is 3, my b is negative 15, and my c is 6. Actually, as I look at that, I just realized that they were all divisible by 3, so I can actually make my life a little bit easier. And not only do I notice there's an x, but I also notice there is a 3 uncommon. So I'm going to divide every one of these by 3x. So 3 divided by 3 is just 1. 15 divided by 3 is 5. And 6 divided by 3 is 2. So now I got even smaller numbers. I have to remember the 3x there. And so therefore now my a is 1, my b is negative 5, and my c is equal to 2. So I get negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 2 over 2 times 2. Two negatives make a positive, so I get 5 plus or minus negative 5 squared is 25 minus 4 times 1 is 4. 4 times 2 is 8. And then 2 times 2 is 4. And then 25 minus 8 is 17. And then that would be some of your answers. But the issue is you cannot forget about this factor. You'd have to set 3x equals to 0. So I'll divide both sides by 3. So I'll also get x equals 0 and x equals 5 plus or minus the square root of 17 over 4. But if you do, if you make a mistake, the mistake will be you forgetting the 0 to begin with. Our number 7 says find the discriminant and determine the nature of the solution to each of the following quadratic equations. The discriminant is only a small portion of the quadratic equation. And it's just going to be the b squared minus 4ac that you would have to look at. If this is greater than 0, there are two real solutions. If b squared minus 4ac is equal to 0, there is one real solution. And if b squared minus 4ac is less than 0, there will be two non-real solutions. Right. So with that said, we have part A here. It says x squared plus 15x minus 7 equals 0. And you're only asked to determine the nature of the solution. So you don't actually go solve them or anything. So I'm going to start by just plugging into this formula. So again, this is A, B, C. So if you still need to do A equals 1, B equals 15, C equals negative 7, and then just plug it in. So I get 15 minus, or 15 squared, minus 4 times 1 times negative 7. 15 squared is 225. And then 4 times 1 is 4. And then 4 times negative 7 is negative 28. With this negative, then makes it a positive 28. And so then that would give me 253, which is greater than 0. So there will be two real solutions. All right, let's look at another one. Looking at part B here, we get x squared plus 8x plus 16 equals 0. So my A is equal to 1, my B is equal to 8, and my C is equal to 16. Plugging into the same formula, I get 8 squared minus 4 times 1 times 16. 8 squared is 64. 4 times 1 is 4. 4 times 16 is 64. 64 minus 64 is 0. So if it's equal to 0, there's only one real solution. And let's look at one more. So part C here, you have x squared plus 9 equals 0. So my A is 1, my B is 0 because it's the missing term, and my C is 9. And so then I got 0 squared minus 4 times 1 times 9. 0 squared is 0. 4 times 1 is 4. 4 times 9 is 36. 0 minus 36 is negative 36, which is less than 0. So there will be two non-real solutions. Alrighty. And then you're going to get questions like number 7, where it's going to say determine the values for C such that a quadratic equation will have one real solution. So you're given x squared minus 6x plus C equals 0, and you want to have one real solution. So as of right now, A is equal to 1, B is equal to negative 6, and our C is equal to C because we don't know that. So using our discriminant, we need to determine how does b squared minus 4ac equal 0 so that I have one real solution. So what I'll do is I'll plug in what I know. I know that b is negative 6, so that's negative 6 squared, minus 4 times a, which is 1, times c, which I don't know, equals 0. Well, in this situation, I now have a way to solve for c. It's a linear equation. So negative 6 squared is 36. 4 times 1 is 4. Then I'll subtract 30. Ooh, 3 went off. I'll subtract 36. And then I'll divide by negative 4. So in this case, negative 36 divided by negative 4 is 9. So if c equals 9, I will get 0 as my discriminant, which will tell me I have one real solution. All right, so let's do the same thing, but this time with the A. So on number 8, we are given ax squared minus ax plus 1 equals 0. And it says determine the solution that will have two non-real solutions. So I'm looking for b squared minus 4ac is less than 0 because I'm looking for a non-real solution. So I see in this situation that a is equal to a, b is equal to -8, and c is equal to 1. So when I plug it in, I get -8 squared minus 4 times, I'll put it in parentheses for now, a times 1 has to be less than 0. Well, now I have a linear inequality, which I know how to solve from our previous chapters. So -8 squared is 64. 4 times a times 1 would be giving me 4a. I'll subtract 64. Now I get -4a is less than 64. Then I'll divide by -4. But remember that one rule. If you divide by a negative, you have to flip the inequality. So therefore, 64 divided by -4. Let's see, 4 goes into 6 one time. Then you get 24, so 16 times, or -16 times technically. So in this case, as long as a is greater than -16, I will have two non-real solutions. Oh, actually, it is positive 16 because that was a -64 when I subtracted. So sorry. As long as a is greater than 16, I'll have two non-real solutions. So there's your answer there. You don't have to worry about graphing it or anything like that. All right, so that's all I wanted to go over in 16.3 to finish up from last Wednesday. And then the next video will be our last video on 16.4 on some application problems of quadratics. I'll see y'all in the next one. Bye for now.